Hey guys, it's EJ with Blockpad, and today, as part of our video series on arrays, we want to take a look at functional alternatives to programming loops. We get this question a lot at Blockpad where people want to know if you can do programming loops in Blockpad, and the answer to that is yes. First, we have inline programs where you can do basic programming tasks inside of an equation. And then also we have modules where you can use our scripting language to do for loops, if else stuff, and define a custom function with that you can use in your document. But in addition to that, Blockpad also has a lot of built-in functions that are able to do the tasks that you might use for loops for in a way that better matches work inside of a spreadsheet. So before I covered inline programs, I wanted to take a look at these functions. And then even then, for the first part of this video, I wanted to point out here with item by item calculations that these can do some of the things that people are looking for programming loops for. So one way to do this equation here would be to have a for loop that loops through A and through B and does this equation on those items. But Blockpad with item by item calculations, they'll basically do that for loop for you, and they will go through A and B and perform this just being written with a regular equation. So in that case, you really don't need programming loops. Now, this is the same for a lot of other programs. I just wanted to point it out. Moving on, the each function works in a lot of ways very similar to those item by item calculations, but it's a little bit more explicit, and it will also work with multi-dimensional arrays and not just those single dimensional arrays. The way it works is you will pass in the array that you want to perform it on, and then a function as the second input. And this function, the argument to it, is going to correspond with each of the items in the array. Now here I have an inline function, and we have a video that covers that, and also how to use them as inputs to other functions. So I'll put a link to that in the description. But here, basically what I'm doing is squaring each item in the array. Here's another example where I have x maps to this if function, where if x is greater than 0, return x, so the item in the array. Otherwise, return 0. So that's going to take all of the negative numbers in this array and turn those to 0. And then also, you don't have to use an inline function. You can use a named function, whether it's from our library or whether it's a custom function that you've created. Just when you pass it in, leave off the parentheses. So here I have d is even, and I've left off the parentheses. And is even is a built-in function that will give true or false based on if a number is even. And here I have the true or false set to y or n in my value formatting. Similarly here, I pass in the absolute value function. Now for that second input, my function, if I have multiple arguments, then the second and third arguments are going to correspond to the row and column index indexed to 1. So as my example here, I have ABC, and then in my definition, I leave off A, and I just define this subarray using B and C, and those are going to give me row and column in each of the different items in that array. Similarly, if I do each on D, I have item, I of row, J of column, and then I want to return the item if the I of row equals to 4. So here the first 3 rows are 0, then the fourth row are the items. Each row and each column are going to work similarly to each, except the argument in that input function is going to be the entire row of the array, or the entire column if you're using each column. So here I have this inline function, and I have row. And by the way, it doesn't have to be named row. It can be named R or anything else. Here I have row maps to the max of row minus the min of row. So that's going to take the max and min of this and subtract them, and then same thing for each of these rows. Similarly, it's going to take the average. And by the way, just like with each, if it's just the function, then I can put in that function without parentheses, and then that's going to work. Press Control Z. And then similarly here, I can use the function sort, which we covered in our last video. That's going to sort each row and then give it to you as an array of arrays, because each of those is the row. And then because I'm not performing any kind of function that reduces that row, it's going to give me the actual array. And if I want to combine all of these, I can use the function concat rows, which we learned about in our concatenation video. And then that's going to combine all of those like that. Press Control Z to undo that. For each row, if you use more than one argument to the input function, then those arguments are not going to correspond to the row anymore. They're going to correspond to the items in the row by their order. So here I have this inline function with the arguments L, W, and H. And those are going to correspond to 3 feet, 5 feet, 10 feet for the first row, and then so on for the next few rows. So when I do L times W times H, the result of that first row is 3 feet times 5 feet times 10 feet. And then similarly here, I have LWH again, but something a little bit more complex to calculate the surface area. Moving on to the last part of this video, the reduce function is a little bit complex, especially if you've never seen it before, so I'm going to take a little bit of time on it. But essentially, you're going to use it for those times in a programming loop where you're accumulating a value over a number of arrays, and then you want to spit out that accumulated value. So the way reduce works is you start off with this initial accumulator value. And then for each item in the array, you're going to run an aggregator function. Now, I personally find those words a little bit too similar when talking about this, but they do mean different things and the difference is important. So that accumulator value here I have represented as ACC. That's going to be your initial value. And then for each item in the array, you're going to run that aggregator function on the accumulator value and the item in the array. And then that result is going to be the accumulator value for the next item. And then you can kind of build it up until you get your final result, which is going to be the result of the aggregator function with the accumulator and that last item. So to kind of introduce you guys to just how this sort of works, I have some relatively simple examples here where I'm recreating some functions that we have already built in Blockpad. So for the first example, I have count, and note that we're passing in nums, which is this array here of just 4 items. It's one-dimensional, 5297. So for my initial accumulator value, I want to start with 0. And then here for my aggregator function, the first argument is the accumulator value, and the next argument is the item. So remember, every time we run this, we're running on the latest accumulator value and the corresponding item in the array. And for count, I don't actually want to use the item because that's not important to count. I'm just going to use 1. So the accumulator plus 1. And then if I do that for every item in that array, then I'm going to get a result 4. And over here, I have the corresponding Blockpad function that's running on nums. For sum, similarly, I'm going to put in nums and 0. And then here I have my arguments running sum and num. And again, these are just the accumulator value and the item. And then I'm going to add up the running sum plus the number. And so for each accumulator result, it's going to build itself up until we get 23. And that's the same value that we get for the sum function. For sum squares, it's basically the same as sum, except item is going to be squared when we add it. For product, for that initial accumulator value, I'm not going to use 0 because if I use 0 and multiplied, then my final result would just be 0. So I'm going to use 1 as that initial value. And then for each of my aggregator functions, I just have the accumulator times the item. And so that's going to build up and give us our sum. Excuse me, that's going to build up and give us our product. Finally, max is going to be a little bit different. For this second input, instead of my initial accumulator value, I'm putting in this very simple inline function, which is just I maps to I. And when you put in a function for that second argument, then Blockpad's going to run that function on each item before it's used in the aggregator function. And also, it's going to treat the initial accumulator value as that first item in the array and not as something that you give it. And the reason we do that for max is because if we put in an initial value, say for example 0, there's a chance all of our values in the array could be negative, and then we'd get a result of 0 instead of a negative number. So anyway, moving on to the aggregator function, I just had this if function where if the accumulator is greater than the item, return the accumulator, otherwise return the item. And so doing that, we get our max there of 9. And that's all I've got for you guys today. I'm going to put a few links in the description, including a link to this file, which I'm using for all of the videos in our array video series, and also a link to all of these functions. So that's it. Let me know if you have any questions in the comments. Thank you.